Wow. Thanks, Gabby. Thank you, everyone, for joining us today. Great video. Exciting to take a look at that again. By way of introduction, again, my name is Michael Marseglia. I'm the VP of Sales and Business Development at Calvary Robotics. And today's discussion is part of an ongoing forward-looking journey that we're all on, I think, together. And we want to discuss the current trends, the future of automation and manufacturing with industry experts that we invite in from time to time. Today, we're featuring two of those, as you saw in the video, and that I'm happy to welcome back very esteemed partners and guests and friends, Michal and Jared. Folks, go ahead and introduce yourselves.
So hello, thanks for having me. So my name is Michal, you saw me on the video. I'm the P3 Product Director from Stratasys. I'm an industrial engineer by education, but I started my way from a technical role. I was a software developer, and I joined Stratasys 3 years ago, and we acquired a company, DLP Technology in San Francisco. I relocated there, and now I'm responsible for that product, which is now being sold worldwide by Stratasys.
Excellent. Thank you, Miguel.
And hi, I'm Jared Glover. I'm the CEO and co-founder of CapSen Robotics. And you already heard from me quite a bit in that video, but just to recap, we provide software that gives robot arms more intelligence, 3D vision, motion planning. It's been in development for a long time. We've been in business for 9 years and started doing some of the research on the technologies before that in my PhD at MIT. So it's been a long time in progress, and we're really happy to have Calvary as a strong partner to help us bring it to market.
Thanks, Jared. Yeah, and today something I'd like to focus on, just remind everyone and everyone here that's joined us today that's part of manufacturing or automation in some way, shape, or form. We understand that the future of manufacturing, the technologies that drive and support it are evolving at a faster rate than ever before. I think we can all agree with that. I'll speak for everyone. In recent years, we've heard, seen, used, and evaluated many new technologies and approaches to manufacturing and automation. Some are commonly known by now familiar industry buzz terms, and that's usually how we first hear of something and then want to investigate further. Things in the past like names like cobots, IoT, or Internet of Things, Industry 4.0, which I think Michal mentioned in her digital twin, 3D vision, AI, flexible feeding, 3D bin picking. Picky and additive manufacturing, of course, not to be left out. We're looking forward to addressing these and more in follow-up conversations, but today we're going to focus on what Jared and Michal are presenting, and that would be 3D bin picking and additive manufacturing. And if you've been in the industry at all, you can agree that both of those technologies and manufacturing methods, not only technologies, but methodologies, are evolving very quickly and have grown to play very crucial roles in many industries that we're all in today. So whether you stop by our booth at Automate or you're just starting your automation journey, we hope this discussion enhances our view, or your view, and ours as well, into the future of manufacturing and automation. And lastly, if you have any questions or comments, please feel free to add them to the comments section. And we'll do our best to address as many as possible at the end of our talk today, and then beyond that, if you want to contact us independently. And with that, I guess I'd like to start into a discussion here. I want to make one comment, and it's off script, guys. No questions that we've actually rehearsed. It's Jared. It's about something I just realized that you said in the video, which is quite interesting, and it's a great comment. You said we can do. I'm going to read that because I wrote it down during the video. We can do a lot more than you think we can do. I love that comment because I think that's something we talk to customers about every day, and I think that applies to you as well, Michal. I'd like to see what does that mean to you, Jared? That statement.
Yeah, I mean, there's a lot of applications that weren't possible a few years ago. For example, disentangling objects, right? You have a bin full of cluttered parts like hooks or springs or something, and they get entangled with each other. And for the robot to be able to figure out how to pick them up and disentangle them is just not something anybody had thought was possible before. And we achieved that a few years ago. That's one example, but there's a lot of other examples where, it may not even be a pick and place application. It might be that, you want to power wash an object, right? So how do you do that with 3D vision? You put the object in front of the robot on a turntable, or you put a camera on the robot arm and have it move around and scan in the object, a 3D model of the object. And then, motion planning software that plans a path to spray it off. So, really the sky's kind of the limit in terms of what you can do to combine these different tools. Just imagine robots, are now able to see in 3D and understand the shapes of everything and where things are positioned and what, which objects are where, and then make, pretty much arbitrary decisions accordingly to do different tasks. It still takes time and integration, but there's a lot of flexibility in how you combine these different core technologies.
Perfect, Jared. That's perfect. Thank you. And Michal, what's that mean for you? You started out, printing parts, right? And what else have you seen that's emerged from your technology that makes it more robust, and that you're offering something different than you were when you started out?
Well, first, we don't know what we don't know. And when we come out with the technology, and that's what happened like a year and a half ago when we launched the Origin printer, we launched a printer and a bunch of validated materials with great mechanical properties. But then the customers kind of found out what to do with it. So they started adopting it in various segments, in aerospace, in automotive, in government, in education. And we were surprised to find out how they use the technology. So we kind of learned from our customers. I have some examples that I can show to the camera later of different things that we are developing here in Stratasys, but these are all things that we are learning from our customers. And once we do that, we kind of produce an application together, and then we can scale it. We can scale it up. So it's a journey for us and our customers.
Very good. Yes, hey, Jared, thanks for that comment, because I think I'm going to make that into a T-shirt. Very
Nice.
important. I think all of us find that the only way that we advance technology is when we realize that we can do more than people think we can do, or that even we think we can do. So it's a very important attitude to have. So great question, great answers from both of you. Let's start out, Michal, with for Stratasys part, from concept to final system at the show. Can you walk us through the evolution of that application? What drove that?
Sure. So maybe first who we are and why we're doing this. So this is a DLP technology, as I mentioned. And the differentiation is that we can reach injection molding quality, surface finish accuracy. We have an open material platform, and we have wonderful applications. And now we want to scale, because if you look at the market, you see that analysts say, that the polymer 3D printing market has a CAGR of 23% in the next coming years, and that over 50% of it is going to be from manufacturing. So we want to be part of that, and actually it's to lead that polymer 3D printing transition into manufacturing. So taking this technology into manufacturing, we are running into various challenges, whether it's the materials that have to be adopted and tested and certified by the customers. We have to prove repeatability. We have to prove quality control. We have to reach the right accuracy. Customers want to avoid the health and safety issues, so we want kind of a glove-free, no touching process. For that, automation is key. And we're focused on 3D printing. That's what we do best. So in order to give the full solution and the automation to the customers, we're partnering. So in this case, we partnered with the Calvary Robotics and also with the EcoClean for some of the post-process equipment. And we show that the purpose of this partnership was to demonstrate how P3 can scale into manufacturing in terms of hardware, material, service, and software. And what you saw there in the video is the 6 Origin printers and a robotic arm picking build heads from those printers once they're finished printing, putting them on a conveyor, which runs constantly through a post-processing operation, which is washing, drying, curing, removing the parts from the build head, and then the robotic arms takes the empty build head and places it back into the printer. So this is like the full what I call a production cell solution that we were able to demonstrate together to prove that it's possible.
Wonderful. And that's and Michal, important to add that those were all processes that previously required a lot of manual intervention as well, right? And possibly or happened much more slowly with a lot less organization and not as good as a cadence to get you the throughput that you required for some of your customers as well. I'm imagining. I think from our part as Calvary Robotics, we see applications very similar to this, not only in the 3D or additive manufacturing, but in many areas of manufacturing where robots are, I'll say, tending different types of machine technologies to either load or unload materials or move them around and keep a cadence going in manufacturing, and perhaps go on and allow people to have more shifts and improve throughput, improve volumes of their manufacturing materials. So something that we see quite often, and we were happy to be able to offer those services to Stratasys, and I think it was a great combination of technologies. So very good. Jared, how about yourself? Referring to the automated show cell, from concept to final system, walk us through the evolution of that. How did that come about?
Yeah, sure. I mean, it was basically designed to be demonstration based on a project that we did together, a medical packaging product at the height of the pandemic. There was a rush job and really came together amazingly fast between us. And it was, picking these medical consumables that were wrapped with rubber bands and then picking them with a suction cup on a robot arm and packaging them in a small part of a box. Now it's evolved to package 3 of those bundled products and then a 4th product as well on the actual assembly line, on the actual packaging line, in a very tight space. They all have to be lined up next to each other carefully. In the demos at Automate, we didn't have the full packaging line, obviously, so we just showed picking from the random bin, and then placing consistently in a chute that comes out of the cell. And then the really cool addition that we made that I think was your idea, Mike, was throwing in some little robot squeeze toys that our system could recognize, and then if somebody presses a button on the outside of the cell, if a visitor presses a button, then the robot would switch and pick up that toy and then give it to the visitor out of the chute. So that was a really cool idea and worked out really well, I thought.
Yeah, Jared, that was a bit of allowing you to show off a little bit in terms of capabilities. I thought it was great myself, but also quite practical, right? If you get a case of if you have a bundle or a lot of products like that come in a box, sometimes the things are mixed and there may be something that doesn't belong in there, and you're not putting the wrong thing in a box per se. So it's a good feature to show off. So appreciate you guys working on that. One thing that becomes obvious as you're talking about both of your solutions, both technologies, is your ability, both technologies, to deal with high variability, right? For yourself, Michal, that means that you can print virtually anything that fits in that machine, right? In any of your systems within the envelope given. And Jared, for you, virtually anything that appears before you in a mix, you're able to pick it as well. So what does that mean for customers, for you, Jared?
I mean, customers that we talk to never want the same thing, right? So, we'll be talking about picking auto parts that are in cardboard boxes with dividers one day, and then the next day we're talking about, picking packages of chicken or something. And there's just so many different picking jobs out there. And then, as I mentioned a few minutes ago, there's more than just picking. There's inspection tasks and scanning and post-processing, finishing tasks, all sorts of different manipulation tasks, assemblies, machine tending. So the variety is just limitless in manufacturing, and so there's always a different request. And we've designed our software from day one to be very general purpose and built in different levels. So at the highest level, we have the applications, the assembly and packaging and pick and place applications and so on in our software. Then we have under that all the core vision and motion planning libraries that are very general and able to handle these different tasks at the higher level. And then even under that, we've written software that is all accelerated with GPU programming, CUDA on NVIDIA chips, which is what all modern AI is based on, basically. And it's all accelerated. So the matrix math computations, the machine learning and optimization, we all have that at the lowest level. It's all been highly optimized, which is why our system is fast and general.
Excellent. Yeah, I'm also thinking of small changes in the product itself that you're picking. If you can adapt quickly to a slight change in dimensions or geometry, or maybe even wrapping, without having to retool, let's say hard tooling, and take a long time to have a new solution come up or to modify the solution. Uh, that means a lot. Time to market, time to react quickly for a customer to any small changes. Or previously, it was a much longer journey, much more expensive one as well. So
Yeah,
great,
exactly. And
great features to have.
that's just kind of the nature of bin picking cells in general, right? The idea is that you're using a very flexible robot arm with one or maybe a couple of different end effectors that can handle a variety of products. And so just by the
Right.
nature of how the cell is designed, it's flexible.
And Michal, for you as well, I mean, you can print virtually anything, but I'm sure, if this was a molded product, for example, if you're molding products, what's that huge advantage you have over something that's molded?
Well, first of all, something that is like molded and someone to do a prototype, and production has many stages. I mean, it starts from
Right.
prototyping, then it goes to bridge production, then it goes to small series, then it goes to full mass production. And Stratasys kind of has the right technology for the different phases or for the different stages in the journey of the customer. So it's not one size fits all. Customers want for different applications, different mechanical properties, different sizes, different post-processing requirements, different certifications, different regulations. So when you come to sell some solution like this, actually you're not selling a technology. You're selling a part, or you're selling the finished part or the pipe, especially in production. You're kind of selling an end-use part to the customer. And he doesn't care which technology is standing behind it, which software is standing behind it. That's all kind of like in the background. He just cares that he gets something that fulfills his requirements. I can share some examples of beautiful things that we're doing in end-use parts in a PolyJet, for example. PolyJet is a different technology, not the one that I've shown here, but it has the special thing about it is that it has multicolors, transparencies, gradients, and it's mainly used for prototyping, but also for end-use parts of fashion, of medical modeling. So I brought a few things that I can share with you. For
Sure,
example,
please
this
do.
is this is the Alexander McQueen shoe, and you can see this is like a shoe that is sold in stores, and you can see here this part is the printed part. I guess that you can see it on the camera. Another example is this bag or purse that is also an end-use part, and you can see the different the textures, the special textures, and the special colors on it. Here is a denture. So of course, this is something that is also an end-use part that has completely different requirements. You have to get a FDA approvals, different kind of regulations and standards. Here is an example of a collectible. So you can see that and the way it looks inside. So this is beautiful and very special in that technology. You can see like hyper realistic parts. Somebody that wants to prototype something or wants to demonstrate something. So you can see that this is actually printed. You can't eat it. And with DLP, one example, one of our special customers is the Echo that produces the shoes. So they produce molds with our technology, and then the molds are used to create the midsoles for these shoes. So these are shoes that are created with the molds that are printed with our technology. So each mold like that can go through 2,000 shots. So different customers, different applications, and different requirements. It's not one size fits all.
Very true. Truer words are never spoken. Yeah, and then the final solution. I like the fact that you were able to customize it right down to the individual, right? For in terms of the shoes, the markings on the shoes. That is another emerging market for a lot of manufacturers, right? To personalize and customize products directly for individuals. That's excellent. In terms of this solution, going back to this, I'll start with Jared for this one. Jared, did this? I already know a little bit of the answer to this, but in other applications of this, did this come directly? Do you usually get these bin picking applications directly from a customer need, the need for multiple cells directly from a customer, or is this just something that you guys have pushed and marketed as a solution that you had imagined would be important?
It was entirely from the market, from customers. So when we started, we were just looking at applications for 3D vision software based on some research I had done at MIT before that. I think I had heard of bin picking, but I certainly wasn't looking to solve that problem. But we just keep hearing it again and again when we started talking to integrators and manufacturers and industry, and it just seemed like a natural fit for the kind of software that we had, and we ended up building quite a bit on that basic software and actually rewriting the software we had originally to make it better and more general. But at the end of the day, it was a natural fit for the kinds of skills that we have as a company, as a software company, for handling the combination of vision and motion planning with a solid foundation in 3D geometry. Being able to do these more complicated tasks was really a good fit for our skill set. Mike, I think we lost your audio.
Sorry. So what do you think about the penetration into mainstream manufacturing for 3D printing? Meaning, not just necessarily off to the side, low volume, but something in mainstream, higher volume manufacturing?
Well, 3D printing was kind of like a promise in the 80s, and it did not materialize. And I'm thinking about it a lot. Why did it not materialize? What are the barriers? And I do see that we experience success with production applications that actually use our technology for production, for small series, for end-use parts. So when looking at those barriers, we see that the customers, first of all, need to get maturity. They need to trust the material. They want to know that it will age properly, that it would last after being 10 years out there in the field. They want to make sure that their operators are safe, that you don't want to get a resin dripping in the production floor. So the acceptance is kind of difficult. What we do about it is actually work with the customers and find out what kind of regulations they need, what kind of certifications they need, and we develop the software that supports the whole operation to be integrated into their systems of record. So when you want to put a printer in a production floor, it has to behave like one of those machines that are used for production. So the hardware has to integrate, the software has to integrate. They're using their ERP system, like maybe SAP, maybe they're using a MES of Siemens, maybe a PLM of Siemens, maybe they're using CATIA, whatever they're using, the BI dashboards. You have to integrate to all of that. So this is what we're working on. We're working on making the acceptance easier, making the adoption easier, and we do see progress in terms of software, hardware, and material properties that are improving over the years to help this adoption.
Thanks, Michal. That's a great view of what's coming and what's currently happening. Very good. Jared, how about you? How's your software CapSen Pick evolving right now for 3D bin picking in the marketplace? I know that you started out, it was a much more user-involved process and maybe required more expertise. I think you've been evolving. What does that look like now?
Yeah, you're exactly right. We're spending a lot of time right now improving our usability and user interface so that anybody can program it. That's the ultimate goal here. So we already have something called an action script language, which is just a basic blocks-like programming environment, scripting environment, really, to get the robot to be taught to do these different tasks with different objects and different setups and configurations. And we're trying to make that as intuitive and easy as possible. So, we were really happy to come up and start training your guys recently and how to operate and program in our system. And we're just going to keep improving it and make it easier and easier as time goes on.
Great. From what I understand that quite well. Our guys were anxious to get their hands on it, and hopefully actually it would be good to get some good feedback from them in terms of a user experience as well. And Michal, in your experience, you mentioned Industry 4.0 highlights. What does that look like in the Stratasys world? Is that, are the analytics used? Are they proprietary to Stratasys, or is it third party? How does that work?
Well, we have our basic platform, which is called GrabCAD, but we're a part of a complete workflow. So we do the print preparation. We have our analytics, we have our connectivity to the production floor systems. But there's a complete workflow before us and after us. So if, for example, you're designing something, the designer is working in a design software, the engineer works in some engineering software and creates kind of the design intent in that, and all the properties and the thermal heating and all the mechanical properties that they want to have for that part. And only once it's ready, we need to adjust it to 3D, we call it DFAM, so designed for additive manufacturing. And only at that point, once it's designed for that, it goes through our software for print preparation, making the right orientation, the right nest, the right placement. How do you want to place those parts on the plate? And also the slicing. And the way it works, we project, our software kind of projects one slice at a time, and we create that slice of material, of cured material, polymer, of the part. And eventually it builds, the part is being built one slice after the other. So this is the role of our software. But because we live in an ecosystem and we have to integrate to everything, so of course we want traceability. So we're collecting data. We want to enable our customers to do audits. We want to enable them to do recalls. So for that, you need the digital thread. You need to know who touched which part, using which resin, at which time, so that you can find anomalies, so that you can detect issues that are going wrong. And we are working on SDKs and Industry 4.0 APIs to integrate to the customer systems of record. And in addition, of course, we're working on our software intelligence, because the software can be very intelligent, but you start from just collecting the data. Then you want to detect anomalies, so you want to alert maybe the user. But then you need a really smart user to look at those alerts and understand what to do with them. So you're actually asking the software more. You're asking the software to predict for you what is going to happen. And then finally, the very intelligent software would automate your decisions. So this depends also on the autonomy that you give the software. Maybe you don't trust the software at first. You want to fine tune it. You want to build some kind of relationship with the software. But eventually, you give the software the autonomy to make the decisions for you. Because our target at the end is not the software. It's for the customer to come in the morning and find the perfect part that is printed. And then maybe behind the scenes, you could get a report that says, while you were sleeping, we did all of that, corrections and analysis, and made it just perfect for you, because it wouldn't just be perfect like that. So that's the role of the software for us and of the Industry 4.0 standards for us.
It sounds like you've taken that quite a bit farther than I would have expected in your answer. I was surprised, to say the least. Excellent. And one question I have for you. So what does it mean when you say in a 3D system, when it adjusts or make adjustments for you? What type of adjustments would it make? What type of feedback does it have to make the types of adjustments you're talking about?
Well, let's say that you detect there is some kind of leakage, or you detect that the part is falling off the build head, or you detect that the build head needs maintenance, some kind of maintenance site, or you detect that the temperature is too high or too low. You can do something about it. You can make the print slower. You can stop the print. You can tell the user, maybe you want to take a decision at this point. You can lower the temperature, you can put the fan on. I mean, so there are many actions you can do, but in order to be able to do something, you first need to collect all the data. So our software aims to start with collecting the data, and we're not trying to do everything on our own. So we're not an AI company, but AI is becoming very popular in manufacturing in general. And we will be partnering with the right partners in order to use the right software intelligence to optimize the parts.
Very good. Thank you. Jared, for you, Michal closed with mentioning AI once again. What is the, I'll say the influence of AI on your solution, and maybe in the future and other applications that you have coming up that you'd be applying your technology to?
So when I think about AI, I don't just think about large language models and the generative stuff that people are so excited about now, which is very cool. But I think back to, even the computers that beat Garry Kasparov, the world champion in chess back in the 90s. And all the different techniques that we built up in the AI community over the last 30 or 40 years, if not longer, that involve, combination of machine learning and classical optimization and geometric algorithms and so on. And it's really about combining all those tools to achieve the best result, without having a massive computer cluster that costs $100 million to run to train these large language model type systems. So, if you really want to have affordable systems that you can use in industry and in manufacturing, you want to have things that combine all the best tools that are efficient and can get the job done.
Thanks, Jared. Yeah, I think for our part, we've run across that in almost every aspect of manufacturing right now. Everything that we're integrating right now has offering some knowledge-based aspects to it, not necessarily to the extent, Jared, that you just described, but everyone has some little bit of sprinkling of that content in it. And we're excited to embrace it. We have a lot of great talent here at Calvary that's very excited about that as well, and very open to a lot of the newer things coming at us. And we're excited to see what's coming soon. On that, so right around the corner. And on that note, I'd like to ask both of you. We can start with Michal again. What's next? 5 years out for Stratasys. What do you see evolving or advancing that's not quite here today?
So our focus is obviously 3D printing, but I think what we understand, what we realize is that when we go to production floors, we're just a small part of the process. So moving forward on the hardware front, we want a glove-free operation. We don't want the operator to come and have to deal too much with the printer. On the software front, I mentioned the intelligence, that we want just the solution to be done for us. We don't want the operator to have to make a really smart person to sit there and look at dashboards and make decisions. On the material front, we want to develop very unique differentiated materials, because the materials are key here, because they unlock the applications for us. On the application front, we want to identify those killer applications, working with our partners. So I think what is like in common for all of these is like collaborations and partnerships. We focus on what we're good at. We partner with partners like Calvary Robotics. We partner with Siemens and Octon and Link3D for software. We partner with Henkel and BASF and Evonik for materials. And we partner with our strategic customers for the applications. So I would say we are part of a big ecosystem, and moving forward, we are going to put a focus on all of these pillars: hardware, software, materials, and service, and partner in order to give the full solution for the customer.
Thank you, Michal. And Jared, how about yourself? What do you see, 5 years out for CapSen? I know that you're venturing out into different types of applications. Your technology is applicable across the board to many different industries. What do you see in the next 5 years that's coming at you that you'd be addressing?
I think definitely more applications, different types of manipulations, and so on. But the big trend that we've already started doing some work in, but I think is going to continue in a much bigger way, is mobility. So putting robot arms on mobile robots, and that gives them the flexibility to drive around, do tasks at multiple stations and in a factory, or for transporting goods in a warehouse. We've already done some work, for example, picking totes off of flow racks, stacking, destacking, transporting them, putting them somewhere else. You could use that to build pallets or break down pallets, so on. So totes, boxes, big objects like that, we've already started doing some work with. But I think one thing that we're gonna start doing pretty soon is applying that to all sorts of different objects. And so you just have a mobile robot, mobile arm that's driving around and picking, doing order fulfillment, driving around, picking objects, and wide variety of objects with the same robot. That's probably the biggest challenge. But picking a wide variety, thousands of different objects with the same robot, driving them around and transporting and doing pick and place jobs at the same time.
So thank you, Jared. I think what I'm hearing from both of you, and I can actually say that for myself as well as an integrator, and what we see most often is customers more and more looking for minimal intervention in any type of an operation, right? Michal, to your point, hands off, gloves on, do smallest amount of intervention. Mean time between failures, very important. Mean time to recover, equally important, right? To keep production and manufacturing moving while addressing any anomaly that might come up or any slight change that needs to be made. Those are things that we see and we face every single day, and we have and we figure out solutions for. And we, in our industry, not necessarily having a specific product, but very often it's a custom, total turnkey systems integration. Doing that at a system scale is actually quite a challenge, and it's something that we work very hard at. Delivering systems that are very high in terms of operating efficiency and low mean time to recover, and then very, very durable, and that lasts a long time. That's to Michal's point, to what she mentioned earlier, what manufacturers are looking for. And then in this future market, what we're seeing currently and in the future, I don't see it changing much. Even with the lowest unemployment rate we've been enjoying in a long time, there still are very, very many open positions in manufacturing that can't be filled, and maybe a high turnover because of the types of jobs that are available, but repetitive jobs that I think Jared addresses very, very nicely with his technology. We'll see more and more of that. Customers are fighting that, and people want to be more fulfilled with the jobs that they do every day. And loading a specific object to a specific box for 8 hours is just not something people enjoy doing, and robots don't mind. And neither does vision or the application of technology that we're developing here together. So we're addressing all those applications as we go forward, and I don't see much of that changing. There's just going to be more of that. Automating the few things left in a factory that are not automated. We see that every single day, and I think both of these guests today are addressing that, and as well as we, together, partnering with them and with others like them, and we enjoy doing that. So that said. What's next on the horizon here for Stratasys, Michal, and the next, let's say, in the near term with the automating, custom automation for your customers?
Mm-hmm. So we've already automated the post-processing. Now we want to automate the printing itself. We want to continue this print so that there is automatic resin feeding, so that the part is removed automatically and fed into the post-processing. And eventually, we want to remove all those touch points and replace them with an automatic production cell to have maybe not lights out operation, but to have a controlled, repeatable workflow without hazard to the employees. Again, materials are key here, and we see a very big leap in progress in the mechanical properties of the materials that we can reach today with 3D printing. Also thermosets, not just thermoplastics, and we see materials, very exotic materials like Henkel 3955 that was developed on the Origin printer that can reach 300 degrees Celsius without releasing any toxic gas, and has a UL 94 V0 and Blue Card certificate. And we see a material that has like a 230% elongation at break. So very exotic materials, and we're trying always to stretch the limits. So this is our focus, and this is the horizon, to kind of stretch the limits and find this unique material that will differentiate us and unlock the new applications for us. And I think there is a big future for Stratasys in manufacturing. I think we will be leading that transformation into manufacturing and 3D printing. And if anybody's following up on the news, you can see that also other players in the market today kind of want to take part in the Stratasys journey.
Thanks, Michal. As do we. We're pleased to be partnered with you and look forward to a long, good relationship with Stratasys. It's a very good, very bright future, addressing some very important needs for the world, for the manufacturing for the economies of all countries. So thank you. I do have a couple of questions that have come in. Actually, one question that came in from one of our viewers. So I'm happy to address that now for myself and for the three of us actually. Someone wrote, I think Carlos wrote, what potential challenges do you foresee in the widespread adoption of automation in manufacturing in the U.S. and what would be your solution? Let's start with the challenges. Go ahead, Michal.
You're asking about the challenges that we see, but specifically in the U.S. or?
In anywhere, widespread adaptation of automation. Yes, in manufacturing in the U.S. Yes.
Mm-hmm. Okay. Well, I don't know if this is special to the U.S., but I think most of the barriers that we run into, it's around material and around trusting a new production solution. And I think it's the same with any new production solution. It's not because it's not personal. It's not because it's 3D printing, but because we're bringing something that they know. So things have to get certified. The certification, for example, for aerospace or FDA, you can imagine it can cost millions of dollars for one part, for one workflow. So this is a big barrier for us. So we have to build those certifications to learn about the requirements of these specific markets, and it takes time and it takes money to enable it. But I think the special thing that helps us is all those advantages that we bring to the table. So with 3D printing, you have a very flexible design freedom of design. You can design geometries that you cannot do with injection molding or CNC. You're not so dependent on supply chain issues. So that helps us as well. In COVID, it was an extreme push for us, that you can just print your prototypes or production parts in-house. Customers are happy that they don't have to share their IP. They don't have to outsource, for example, to send it to another country, to have it prototyped for them. So you can have those fast iterations. So you design something, and then in the morning, you can hold it in your hand. You can hold it, and it becomes reality after one night. And you can put it in the hand of decision makers. So that the time to market here, I think, is key, and where the market is going with those rapid iterations, expectation for a faster production processes, I think this works for us. The thing that we have to understand is where our borders are. Because when you go to replace some kind of injection molding makes sense when you have time to produce a mold, when it makes sense, but because you want to produce millions of parts. But let's say that you want to produce small series of 100,000 parts. This is where we can help the customers, or even those that are producing injection molds, start with additive manufacturing, and then scale into those millions. So these are the challenges, but this is how I think we will overcome them.
Thank you, Michal. What about you, Jared? Same question. What potential challenges do you foresee?
It's similar. I think it's the flexibility that's really the hard part, right? So every manufacturing operation is different, right? Sometimes you're, lots of different objects to pick, obviously, but sometimes you're picking and you're just placing something on a conveyor belt, which is not too hard. And sometimes you're picking it and you're putting it in some very, very tight fixture and in a specific orientation with a tolerance of less than a millimeter on each side. And then you have to inspect it. And then if it's not correct, you have to pick it up and try again. And there's just all sorts of complexity and variation in the different manipulation tasks that are out there, all sorts of different machines that need to be tended and assembly tasks. And, so that's why we focus so much on designing our software in such a general way so that you can apply it to all these different problems, but you still have work just on the hardware side and the design side to figure out what kind of robot arm and what end effector you need and putting all the pieces together. And so that's really the biggest challenge in terms of mass adoption. But the better tools get, on the software side that we're providing to make it general and easy to use, and the better tools we get for end effector design and so on, that's just going to become more and more efficient.
Thanks, Jared. Yeah, for my part, I'm going to have quite a few opinions on this, but I think what I've seen, okay, very, very simply, COVID played a huge part in this, of course, but I think manufacturing was going there anyways. But it was accelerated by COVID and by the fact that we couldn't be in the workplace. Workforce was barred from being in the workplace. We had to distance ourselves, where less people available. And then very few people went back to work and back into the jobs that had been vacated during that time. So, potential challenges do you foresee in widespread adaptation of automation? There's no issue with widespread adaptation. I think there's a great desire that was brought around about simply by COVID, and then the years and the months and years that follow. The desire is there, the intent is there. The understanding of what someone might be asking for that maybe hasn't previously automated, that's the challenge, to help them through that process. And the other thing is to whatever solution that we all collectively come up with for together for these manufacturers, that it's not overwhelming to them, that it's something that they can actually operate, own, and enjoy and profit from, and allow their businesses to move forward with what we actually provide for them and not cause more difficulty than they had before. So definitely selling a solution that's benefits the person, the company, the manufacturer, and one that they can sustain, that they can maintain, that they can operate, and ease of operation, and then something that's long-term for them, that helps them on their journey and continues to help them to grow. I think that's really it. So the solution basically is to give them something that's appropriate for what their needs are and that they can support. And then what Michal and Jared have stated is only supports that and only plays into that. So that's something that we're very much dedicated to here at Calvary, and that we're sensitive to, and we can understand during conversations with customers what they're really looking for. So that's my take on that. But hey, I don't see any other questions at the moment. If there are some, feel free to just jump in anytime. Right now, I do have a couple of other questions for you, Jared, and for Michal. I think early on, I'd like to understand. I'll start with Jared. Jared, what in terms of specific industries, who were your early adopters? Like, what industry would have been your early adopters for your technology, for what you were trying to develop?
Small metal parts manufacturing, that was kind of the key entry point for us. So our first installation was a wire and spring manufacturer here in Pittsburgh, and was picking hooks out of bins. It was a part of a larger assembly tasks where the hooks had to be picked and grasped in a certain way and inserted into a press that flattens one end, and then they get assembled with a spring later on. But yeah, small parts are something that there's a lot of trouble, like there is in all manufacturing, but especially with those smaller manufacturers, a lot of trouble keeping workers, especially doing those very tedious jobs, sticking their hands right next to big presses and not flinching, right? So there's a large desire to automate those kind of tasks, and it was difficult to automate them with the tools that were out there at the time, not just the disentangling part, but the complexity of the objects, the bin picking nature of the task, obviously. There really hadn't been a lot of solutions for companies like that previously. So that's where we got our initial traction. But then fairly quickly after that, we started working with you guys and started, getting some traction on the medical side. And that's been continuing ever since. I would say medical is probably our biggest one now.
Excellent. It's good to know. Thanks, Jared. And Michal, What were your early adopters? What industry would have been for you the first one that said, yes, we want to do this? This is a great solution for us.
It was very, very segmented. So I think our number one was automotive, but also aerospace and government and service bureaus that do all kinds of things, and also education, because we are an open material platform. So once you're an open material in education, or when you're developing something on our technology, you want that. I mean, you want to be able to fine tune and optimize the material that you're developing, or your part, to be just perfect for your process. So the open material platform was like appealing to some types of customers. But then we were surprised that some of the others, like for example, suddenly we saw that companies that produce windows are interested, and we have like multiple customers that produce windows, and they print the clamps for the windows. So things that were surprising for us. different kinds of manufacturing aids. For example, we have a customer, Valiant, called Valiant. This is a customer in Canada, and they produce manufacturing aids for the automotive sector. So they produce handles and frames for tools that are used for producing automotive and parts that are used the cars of the car, the doors of the cars. So I think automotive was the first one, but then like various other ones that have to do with sensor flows, with brackets, with housings, with clamps, with seals and gaskets. With our elastomers, they're using many for seals and gaskets and things like that. So these were the early adopters, and from all of that, we have to now recognize what is the true potential here. And then when we find those success stories, we have to replicate them.
Very good. That actually leads into my next question, and I'll start with you, Jared. Again, that's very good. What would you say? So you mentioned the early industries, right? The small parts manufacturers, and then medical is definitely a great spot for kitting and packaging for yourself. What industries aren't you in that you think would be benefit from your technology that you'd really like to break into? What's poised to break open next for you?
I think logistics, we're starting to get a little bit into logistics, like I mentioned before, mobile robots that are moving totes around and so on. But I think there's a lot more opportunity in logistics that is untapped right now. And I mentioned that earlier, having mobile robots drive around and pick thousands of different products, order fulfillment, that sort of thing. But I think that's really just at the, industry-wide, not just for us, but industry-wide, that's really not widely adopted yet by anybody, and will be soon. Very
good. Michal, what about you? You mentioned your breakthrough industry being automotive. What industries aren't you in that you think could benefit from and that you'd really love to break into?
Well, still, it could be in automotive, but maybe different kinds of parts. Where I think I have a good potential to start and scale is things that maybe are not mission critical. Because when you want to try something new, you probably don't put it under the hood, or you don't put it in mission critical components. So an example could be interiors, like interiors for automotive and interiors for aerospace. I think there is a lot of potential for medical appliances, like medical tools. We have an example of like a cover of an endoscope, but I think there's a lot of potential there because of the good mechanical properties of the that is differentiating our technology.
Very good. Thanks, Michal. Hey, so the other thing, I mentioned something earlier when we talked about some things that customers are looking for today. Number one, mainly is ease of use or ease of operation. And Jared, how are you addressing that right now in your systems? What have you changed to make that easier for customers to own and operate, and then to maybe even to modify as they need to?
Well, we put a lot of work in our user interface, as I started talking about earlier. Basically, we try to give as much power and information to the user as possible, while separating it so that it's not like all thrown at them at the same time, but like there's a main screen that they see for the main operation of the system, with a start and a stop button and a few indicator lights and an image, and that's about it. And then you have other tabs you go to on the UI where you can see the action scripts where everything's programmed. You can see the device configurations. You can see the environment model. You can see, the object, all these different things. And so kind of separating it, but giving the power to give these different views into different aspects of the system and make changes is really how we're doing that for our main UI on our own monitor. But then a lot of it, what it comes down to with more complicated systems, like the work we do with you guys, where there's a whole line of robot cells and other cells that are not bin picking cells that are all controlled in the same integration, is we give a lot of information. There's a lot of communication between our computer and the PLC and your HMI that is sometimes what the user is mainly interacting with, right? And so lots of communication between our systems so that things can be done directly from the HMI that controls the whole line without ever going and needing to get into the details of our user interface, unless you need to actually reteach something. So I think the combination of both of those, just giving a lot of power, streamlined power in our user interface, and then the communication with the larger system.
That's great, Jared. We do like to have the choice of being able to control from our own HMI, or B, have a very comprehensive, easily understood user interface for a product that we're integrating. So, and that helps us and our customers. So very good. Michal, what about yourself? Is Stratasys addressing the ease of use at all? I mean, I'll be perfectly honest. I've never operated a Stratasys printer. What are you doing to address that?
So we do a couple of things. First of all, in terms of software, we're trying to automate the workflow. So imagine that you're getting requests from all kinds of stakeholders in the organization. But some software has to take all of that and kind of nest it on build heads and send it to printing. So you need integration to your MES system, and you need to be able to do those nests and decide which prints goes with which prints on which technology and when. So you need scheduling software. And this is, so the full workflow, I call it like CAD to part automatic software. So this is one thing that we're working on. In terms of hardware, so automatic reading, because the resin in this specific technology, DLP, is kind of a pain point. It's messy. You have to, it can spill, you have to touch it. So we want to automate the resin feeding, but also we're coming out with a bunch of accessories that will help you deal with that. So when you're carrying the tray, you put it on a special pour jig, and then you can recycle your resin without really touching anything, without risking of spilling anything. You can recycle and put it back into the bottle. We're using a special device that filters the fumes that are extracted out of the printer. So we want to make sure that the users don't have to worry, that the customers don't have to worry about fumes coming out of the printer. And also, in terms of the hardware itself, the printer itself, we want to reduce maintenance. We want to avoid calibration. So we're introducing now an advancement that the calibration will be done on the manufacturing line, but then the customer himself will not have to worry about calibration, or not have to worry about the degradation of the projector. So we will identify that and adjust the irradiance on our side. So these are kind of the things on software, on hardware, on accessories that we're trying to provide, just to make a better user experience.
Thanks, Michal. Great answer. And again, I still don't know if I could operate a Stratasys printer, but I think that you guys are addressing everything that your users absolutely need. Fantastic. Jared, I had a question for you that came in from one of our listeners and viewers. I'll just read it verbatim from Scott. I see on the website that CapSen software is robot and camera agnostic. Is there any interest to broaden the scope to linear motion system, for example, gantry pick and place using servo motors and drives? It's a great question.
It is, yeah. So we haven't used only gantry robots, but we have put robot arms on linear rails to give them the 7th axis, wider reach. That's been quite successful. There's no reason why we couldn't use a pure gantry system. Our software, like you read, is completely agnostic and very flexible in terms of the kinematic arrangements of the different joints and degrees of freedom in the system. So that's all quite flexible and configurable. It's just that for the most part, the requests we get, the need we see is for these regular 6 degree of freedom robot arms that are not the Cartesian ones, but we can support any of them.
That's great. That's a question I was going to ask you myself, but someone beat me to it. That's a great question. So thanks for that answer. And we're starting to get close to running out of time here. So I'd like to close out right now. And first of all, thanks Jared and Michal for joining me here today. I know your time is very valuable, and appreciate the time you spent here to prepare and also to be here today with us. And also to our listeners as well, thank you for taking time out of your busy days. I know whoever's interested enough to be listening also has a job that requires a lot of their attention, so we appreciate your time. I'd like to say thanks to our guests, to viewers. listeners and future listeners, I say because there's a recording of this conversation that will be available on demand in case you missed anything or want to rewatch or share. That said, feel free to give us a follow on social media. Stay up to date with us. We are at Calvary Robotics on various platforms. You can email me directly if you like, or for any questions you might want answered that might come up later. Make sure to visit our website, calvaryrobotics.com, and to subscribe to Cal TV and the podcast called Advanced Automation for other great industry conversations just like the one today. Thanks again for your time. We really appreciate it and look forward to seeing you again. Thanks.